gathering and other broadband satellite application. So we know if you change framing structure, if you change coding, basically you have a totally new standard. And if you look at the application, we have broadcasting. That one is coming out of the DVB-S. And we have news gathering. This one is basically replace DVB-DSNG. And now he adds the 2-stage, add interactive service. So actually, like before the internet dot-com really crashed, at that time, they did a survey. If you look at all the transponder in the sky, pretty much by that time, around 2000, close to 50% is actually transmitting data instead of video. But at that time, you have to use something called MP, right? You do encapsulation, convert IP into a transport stream packet. So it's very inefficient because you have like a 1500 byte packet. You have to chop it up and put into 188. It doesn't make sense. But at that time, that's the only concept that people can quickly adapt, right? Because we know how to handle transport stream over IP. So if you convert everything into transport stream, satellite can do it for you. So when they start working on DVB-S2, interactive service is already on the mind. We have to find something which can natively transmit IP without going through this MP encapsulation and convert it back to transport stream packet. So this is something there. And also, you have interactive, so the invasion, there's some two-way going on. And also you have a broadband satellite application. It's like TDMA, DVB-RCS come up. There's also like, if you look at RCS, it's also big chunk of them is actually new tech contribution there. So in 2005, we have our TDMA, we call it two-way set. But we start around 2007, 2008, and then iDirect, Viasat, EMS, PowerSat, these people keep going. They become RCS compliant. But that's a different story, why we withdraw from that market. So, but now you know, when you look at the DVB-S2 standard, they already have this in mind. So they want a standard which can like really address this market instead of like a patch or band-aid solution. So the first draft was released in 2004, and 2005 that's the first official release. But in the same month, so we already started delivering our modulator because when the standard was writing along the way, new tech is inside, so we know what will be part of the standard. So when the standard released, our product is already started selling. And then you have a second release. There's some mistake, there's some error in the efficiency, especially APSK. And then you have the most recent release 3. Basically, it's also new tech solution. We propose something to basically allow the construction of a DVB-S2 baseband outside modulator. And then you send it to modulator in something called S2 baseband. But how modulator will know I should modulate this signal? So we proposed something to put two transport stream packets in front of the standard S2 baseband frame and let modulator know how you should modulate the baseband coming over. So DB organization adapted our proposal, and that become the most recent release to handle ACM. So that's the background. The reason they are doing this is very clear. If you look at actually they see first country starts getting controversial now recently. So if you look at the whole thing, right? This is what we learned all the way. This red dashed line, that's called the Shannon image. So basically, if you are in a white noise situation channel, if you want to move information from A to B, minimum power is defined by this Shannon limit. So you cannot go beyond that. If you go beyond that one, you cannot get error-free transmission in a noise channel. So this is DVB-S. This is a DVB-SNG, DVB-SNG. So when people look at this one, they say they're about 2.5 dB away from the Shannon limit, right? So people want to get that one back. And look at another way, like if you turn this 2.5 dB into higher modulation, then you pretty much get at least 30% efficiency, right? So basically, this is why people working on like a higher scale on DVB-S2, they want to go as close as possible to the Shannon limit. So right now, if you look at DVB-S2 away from Shannon limit is only less than 1 dB. So that's why back then, the guy, the Italian guy said, DVB-S2 is the last standard. Basically, he was saying right now, QPSK, APSK, you are only 1 dB away from the theoretical limit, right? So there is, you don't need to find a more powerful code to get the DVB-S3. But definitely that's not going to be the case. First, people will work on this one. If you look at it, people is going to look at 16 APSK, 32 APSK. Here, DVB-S2 you still have a gap away from Shannon limit, right? And also, people is going to go higher. People will do 64 APSK. Actually, now we already have it. There is a company right now is challenging Shannon limit. So we'll see how that will play out. Because for me right now, I don't believe that. Because that's for only 40, 50 years. That's has been tried many times. Nobody ever challenge Shannon limit. Now these group people they said they can do. But we did some analysis. We don't believe it. We don't believe that efficiency is coming out of going beyond Shannon limit is because of playing of raw factor. But we'll see, because they didn't tell the detail. So what I'm trying to say is yes, there will be DVB-S3. You will see people start using certain APSK. Like I remember CBS 5 years ago when I go to they have a qualification lab when I work with Greek. Nobody believed DSNG is going to go 60 APSK, but CBS did it. And now ESPN and the other company in Canada, they are actually doing transmission in 32 APSK for the NFL playoff from US to Europe for the international rights. So they are doing it. And yesterday, about 2 days ago, they just did another 32 APSK, another company in Florida. It's very promising. And it's only like transmit a 5.5 meter, receive 3.3. So it's not like you have to have a huge antenna. So you'll see 32 APSK pop up, and then you'll see 64 APSK coming up. So basically, if we quickly look at it, in general, DVB-S2 have about 40% more efficiency than DVB-S if you maintain the same power. So 30% roughly come from the better encoding. So there is no more Verturbine. It's replaced by LDPC, and there is no more Red Solomon. It's replaced by PCH. And also it's introduced 2 more modulation schemes. One is a 16 APSK, one is a 32 APSK. And later on we'll see why they will do that, because they get rid of 16 Huang. Only very, DVB-SNG has 16 Huang, but only very limited application actually use it because of the constellation. The square constellation, people don't like it, back up too much. And they add 1 more raw factor. Now you have 20%. Before you have 35% for DVB-S, 20% And there are some new features. Before we know one carrier, right? Inside, you can only transmit one transport stream. If you want to change anything, the service has to drop first. But now, you can do multiple streams in a single carrier. So later on, we'll see how that play out, why you can do that. Basically, later on, you'll see it's already changed the whole continuous transmission of transport stream into a TDM system. That's why you can do multiple stream. And also, they introduced something called the variable coding and modulation. So before, one carrier, you can only fix one modulation coding. You change it, you have to drop the service. Now inside, you can have a different mod card associated with a different string you put in. The third one, and also, they introduced something called adaptive coding and modulation. So if dynamically you can tell me the changing receive condition abnormal, I can change my forward mod card based on your receive condition. So totally throw away the margin you reserved before in case there is a rate phase or interference or anything. You don't need to reserve it because I'm constantly receive your feedback. And